afternoon. So today with me, my colleague DK is here, and he is from the mechanical and the aerospace background, and he has completed his masters. Then now currently he is pursuing his PhD. Currently he is in the third year of his PhD, and the area of domain he worked is basically related to the solid mechanics and then fluid mechanics and how this interdisciplinary things between the CFD and finite element analysis. So that kind of stuff he is exploring for his PhD. So without any delay, let's start and then understand about his working and then how he is exploring these subjects and how he can guide to the students. Hello, hi, DK.
Hello. Hi, Suraj.
Uh, so, what are the key subjects do you recommend in the this fluid mechanics, solid mechanics, and CFD and finite element analysis?
Yeah. So basically, if we talk about like solid mechanics, this is very good and interesting subject in which we students can learn about vibration analysis. Let's say if we see take any Burj Khalifa, any building or an engine or any mechanical systems. So there is very chances of a resonance condition. So to avoid resonance, we also need to understand what would be the causes of vibration. So to understand all these problems, we study this vibration analysis, and that we can do nowadays. We have the softwares where we can implement the theoretical knowledge of solid mechanics for the practical applications, like CFDs, FEA softwares. We have like ABAQUS, ANSYS. There are multiple softwares is available, but mostly that is which is used to solve the structural problems, which is based on finite element methods. That are ANSYS and ABAQUS, which is widely used. So and in these softwares have capabilities to solving thermal problem as well, which is related to fluid mechanics. So the forces like drag, lift, which is generated by with the influence of the fluids. And if we talk about in terms of solid mechanics, there are forces, how much forces it is generating, and what would be the moment, uh, and all the parameters that is required for the design consideration for developing any product. So these are the two major softwares that is used, ABAQUS and ANSYS, which is based on the FEA. And for Fluent, there is also one ANSYS Fluent, which is purely dedicated for solving problems of the related to fluid mechanics, and that is based on the finite volume method, which is under CFD, computational fluid dynamics. So if students are well acquainted with these two problems, can solve these two problems, have that is called FSI, fluid structure interaction. So if we combine these two, we can uh, solve the exact real life problem. Because if we say any structure, there would be force would be also like wind is also blowing. So there would be impact of fluid as well, and the structure itself is having a solid materials. So inherently there would be also stresses and would also be generated with influence of the fluid and air flows. So so that thing is so this interdisciplinary, by combining both the problems, actually a real problem we can solve. If we say just only solid mechanics, we solve the problem, that is also good. But if we solve the by combining both, we can come up with a very good solution that is required in industries and uh, real life practical applications. Like that, I'm working on the application of the aquaculture. So, which is for fish and shrimp farming. My background is mechanical engineering. Uh, I have never gone through this aquaculture anytime because I belong to North India. So there mostly agriculture I heard. Uh, but first time when I came here in south side, so I heard about aquaculture also, and I started working on this project which is institute has given me. So I used the both the problems like solid mechanics and fluid mechanics, combining both and solving the problem uh, that is related to the aquaculture industries. So yeah, that is the
Okay, okay, understood, understood. Okay. So thank you for in detailed description about all these fields, DK. So let's see if you student wanted to go from the basics. So let's say solid mechanics is one of the subject, right? So what are the key topics you can suggest for the students which are very important in the solid mechanics?
Yeah, in solid mechanics, that is that I just told vibration analysis, modal analysis, where we
Mhm.
study the what would be the condition that can cause resonance, in which we find out the natural frequency and mode shapes. What
Mhm.
i- at what frequency we should avoid any structure to vibrate so that it does not have hazardous effects. Like if we say Tacoma Bridge collapse was happened in 19 something in US. So that was happened because of this vibration was occurred. So because the so that's what it is also need to be studied, which comes
Okay.
under the solid mechanics.
Okay.
Second thing is design,
Mhm.
like forces, calculation of force, movement, how much any material can sustain the load. That we also study this in solid mechanics and basically for the design purpose, designing any mechanical components. Yeah.
Okay, okay, understood, understood. Okay, so this is all about the solid mechanics. Now coming to the fluid mechanics. So what exactly it deals with, and then what kind of key topics students should focus on in the fluid mechanics. So if you can tell, then that will be very helpful.
Yeah, sure. Yeah, in solid mechanic, in fluid mechanics, generally we talk about vortices, which is generating. Like if we take an aeroplane, there we use the airfoils, and if wind flows there, it generate the vortices. So vortices, it is trying to help in generating the lift. So generating the lift, and we also study the how we can modify the shape like
Mhm.
pitch angle and something like that so that
Mhm.
we can generate the more lift. So these are the things that we study basically in fluid mechanics, or you can say aerodynamics.
Very nice.
Basically, fluid mechanics and aerodynamics both are quite same. In fluid, we generally talk about water, and in aerodynamics, we take the air as the medium. If
Oh,
we see like underwater vehicles nowadays, we can say it is a very boom kind of technology which is developing
mhm.
in submarine unmanned aerial vehicles or water vehicles also.
Mhm.
So, so in that area, if students can work and for developing all these water vehicles and air vehicles, students are really required to study
Fluid mechanics
CFD.
or aerodynamics.
Yes.
Okay, okay, understood, understood. Now, like going ahead with the next subject, which is like which you are closely working, which is CFD basically, right? So then, what exactly is the CFD, and then what it deals with, and then what are the key topics in that also?
Yeah. CFD basically is the computational fluid dynamics in software. we solve the problems rather than by doing the experiment also we can do. But to avoid the experiment, we do the simulation. So for that reason, that CFD has been developed. So in software, we replicate the same exact model that we are going to do experiment, and same uh, boundary conditions we apply. Like boundary condition, if we take an airfoil, it is fixed at the end, and fluid is flowing parallel to the perpendicular to the airfoil. So same thing, we same boundary condition and forces and fluid velocity also we apply in this computational fluid dynamics softwares, which is basically CFD softwares, and we solve these problems. And if
Oh,
we take about FEM, finite element analysis, that is used for solving the problems in solid mechanics. Like let's say, if if we take the example of Burj Khalifa as well, there is a structure. So wind is blowing, so there must be stresses would generate, because if
yeah.
we apply some force, obviously internally forces will generate, that is called the stress. Internally
Correct.
it will develop. So
Mm,
to analyze that, we in finite element method, what we do, we discretize the complete domain into small sections,
mm,
and and we apply the conservation of that we have in solid mechanics, like uh, governing equations that we call, like Hooke's law or equilibrium equations or stability equations. These are the governing equations we solve. And with these governing equations in software, we don't have to do theoretically solve these governing equations. In software itself, like in a finite element method, based on finite element method, there are softwares like ANSYS and ABAQUS that I already told. So in this, they solve these governing equations, that is from the based on the solid mechanics, and we get the problem like how much load it can sustain. Yeah.
okay, okay, understood. So this is a very good description for each and every subject by you, DK. So going ahead, what kind of tools you already have mentioned some of the tools which are like ANSYS and then Abacus basically for this final element analysis. So other than this, what are the tools students should focus on or should use basically for all this domain basically?
Yeah, there are another software also, like
Mm,
OpenFOAM, which is open source software. There is no license is required, so
mm,
students can go through that, but it requires very lot of time. You have to do coding by your own self. But advantage is that if you well acquainted with this OpenFOAM, then
mm.
you can solve any kind of problem. If
Oh,
we say about another commercial softwares, ANSYS and ABAQUS, they have some certain limits. But
okay.
in open form, you generate your own codes for
Mm,
solving that governing equations that I already told,
uh,
based on your specific problem.
okay, okay.
Yeah.
Understood. So what are the limitations these ANSYS and ABAC is having compared to OpenFOAM?
Uh, because they have predefined codes,
Mm-hmm.
uh, and in we can't customize the codes in ANSYS and ABAQUS. But in
Oh,
open form, it is open source, or everyone can use the already developed codes and can modify and apply according to their program.
okay. Okay. Understood. And then like going ahead with the some of the projects, which projects should this master students should take, which will be also give them idea about the whole domain also, and then get some skill sets also and some real life practical implementation also. So would you like to suggest some of the project topics?
Yeah, projected topics, I would say nowadays, like on 3D printing, they can work on, and or and all these where the applications is required like solid mechanics and fluid mechanics. Also, they can work in aquaculture sector. If we see fish and shrimp farming, basically shrimp, there is a huge market demand in the worldwide. So for sustaining, like I'm developing an aerator that would be beneficial for the farming of these industries, aquaculture industry. So in the same way, they can
Yes, I guess you are not audible. Yeah, so we were discussing about the projects which student can explore. So can you please add on something on that?
Yeah. So, yeah, the projects that students can work on, like real life problems in aquaculture sector, unmanned aerial vehicles, 3D printing. There are the boom demands in mechanical field, if I can must say.
Mm-hmm.
So, yeah. So, one more thing that I forgot to mention, that one software that students should also learn, that is CAD, computer aided design. Because
Mm-hmm.
if any problem they are about to solve, they first need the 3D modeling of that. So
Mm-hmm.
this SolidWorks, which is very easy to learn and can be used to make any 3D model of your problem. And then you can import your 3D model into your CAE, computer aided engineering softwares like CA, ABAQUS and ANSYS to solve your fluid mechanics and solid mechanics problem. So so yeah, so this is one of the also software that students should learn in mechanical engineering. That is called CAD, computer aided design. One is SolidWorks, and another software is also that is CATIA. Both are quite popular and good to do any design. Yeah.
Okay, okay, understood, understood, DK. So, like, you have explained about the subjects and the tools and the projects also. So now we are at the last phase of our discussion. So you are doing your PhD and working in the domain of mechanical engineering. So, what is your in general suggestion to the students who are also pursuing the same things?
Yeah. Nowadays, if I say the industry requirement is skills that students are lacking because of our education system, you can say, or anything. I remember when I was working at Skill University, which is first government skill university, which is set up by government of Haryana in Gurgaon. When I was working there, they implemented the dual education model. They 6 months students will learn all the theoretical subjects in university, and next 6 months they will go to industries. They had tie up with the good industries, and they get exposure there. So that is the thing that we are lacking in most of the universities and institutions. So that is the skill set. So
Oh,
skills, like I told, so learning softwares, like in design, if I say SolidWorks, CATIA, ANSYS, ABAQUS for solving mechanical problems. So if students have the skills and skills of coding also nowadays, it is also good. If any mechanical engineer, if a mechanical engineer is also should have coding skills nowadays. Uh,
mhm.
yeah, so these are the things. If students have these skills, they can easily get the job in the industries. So that is demand of today's world.
Exactly, man. That is true. Yes, thank you, DK, for your guidance and the valuable guidance and the inputs, basically. Hope students also find it helpful. Okay. Yeah.
Yeah, welcome.
Yeah. Thank you. Bye.
Thank you.
Yeah. Have a nice day. Bye.
Bye.